What's up, friends? Right, so today's going to be a little bit more boring than usual. Yeah. So yeah, what the plan is I'm going to write a blog post. So you can watch me write a blog post if you want. Like I said, probably going to be a little bit more boring. I have live streamed blog posts before, and some people do watch, but one second. Okay. Hold on a second. I just messed something up. Okay, there we go. Okay, cool. There we go. Should be good now. And sweet. All right. So I've been working on this on and off for a couple days and never really just like focused on it. So I'm going to focus on it. And that means I think I'm not going to do any chat. I'm going to close chat. I'm going to close Slack. Oh man, somebody's replying and I'm kind of curious what they're going to say. I'm going to close calendar. I'm going to close this and email and VS Code. I think I may need it actually, so we'll keep that open. And man, I'm very interested in what this person is going to say, so I'm going to leave their thing open. We're going to close this. Oh, I'm going to look at, oh, no, just kidding. I'm going to close that and close this. Okay, they stopped typing. I can always see what they're going to say later. Okay, so now we are focused. Minimize player. Okay, great. So, oh man. Okay, yeah, we'll look at that later. So I feel like the opening's good. Oops. I'm pretty sure that blue sky invite was used. So you can feel free to try and use it. It's all yours if you want. But I'm going to delete some of that stuff from my clipboard. All right. You know what? We can do simpler. What if we do... Yeah, let's go even simpler than this. So if we have function get get pi, then ChatGPT, how do you calculate pi? Compute pi in TypeScript to 10 decimals. Yeah, inference rocks. Okay. This is computationally expensive, so let's cache it. Function here, let pi function compute pi here, and instead of compute, let's say get. Or you know what, compute pi is fine. And then function compute pi cached. If pi, return pi, else, or yeah, whatever. Otherwise, pi equals compute pi, and, or here, let's do this, return pi. And so if not pi, then pi equals compute pi, otherwise return, yeah, and in any case, return pi. There we go. That's it. That's caching. Caching in a nutshell. It's basically store the result of a computation somewhere and return that stored value instead of recomputing it again. There you go. That's it. Let's see. Let's check ChatGPT's work here really quick. That looks right. Okay. That's fascinating. I have no idea how that works, but okay. Great. So interesting. What if we expand on this and allow people to, okay, let's expand, here I'm going to give it a little space on this example a bit and say people want to be able to supply their own precision. Okay. Yeah, here's my implementation. Update this to allow people to supply their own precision. Hold on a second. Does toFixed return a string? It does. Rats. Let's alter it to return a number. We can ditch the toFixed if we need. We haven't removed the toFixed. So we kept the toFixed, but then you numberified it. Swap the with the number constructor because that's more clear. Here we go. Use inference as much as possible. No. Nope. We're going with this one with a slight change. No more colon number. But yeah, let's just check this. Compute pi. Three, 4, 5, 6, 7, 8. 80. Do. Ah, rats. Oh, that's interesting. Huh. Let's get rid of toFixed. How would you do this without that? Pretty sure I know how to do that, but yeah, math round would be just fine. There we go. Interesting. Okay. When I try compute pi 80, what is the error I get? I get nan. Whoops. I meant when I try it with 800. Don't we have an implementation of big, or what is it called? I can't remember. Doesn't matter. Doesn't not matter even a little bit. So let's just go with this. And just realized semicolons are garbage. Get rid of that nonsense. Get that out of my life. That's interesting. Give me this without the precision argument. And with the 10 precision. Without the big. Without the precision variable. I just wonder if the factor is only necessary because precision is a thing. Ah, interesting. Yeah, okay, we'll go with that. That's fine. Okay. Wait a second. 1E10. Interesting. That's not the same as this, is it? Yeah, I didn't think so. get rid of that. We don't need that. Okay, great. Put that down there. Now, our cache needs to change a bit because we no longer have a single possible result of compute pi anymore. Okay, whoopsies. Okay, so then we say pi cache at precision. And there's that. This introduces a new and important concept of caching for most caching implementations. It's called the key. A cache is normally capable of storing many values, or a cache can be thought of as, or a cache is normally oh, hold on a second, I just realized I forgot to turn on my overhead lights. That's why you're seeing right there, that little corner that looks funny. 1 second. There we go. Paid good money for those things. For good reason. A cache normally has, or normally a hash map. Wikipedia hash map, link to that. Or a hash table, here we go. Okay, maybe not hash necessarily. That's lower level than what we're working with normally. I mean, under the hood, the object is probably implemented in that way, but we're not going to work with it that way. So, a cache normally has is normally used to store, key value store. There you go. That's a good one, Tobias. Thank you. Normally I ignore chat, but I'm actually I don't even have Discord open right now to help me focus. I probably should close chat to stay focused, but that was helpful, so thank you. Is normally a key value store to make it easy to store an arbitrary number of cached items but also to easily find the cached value you're looking for. The key is critically important to this. Using the proper key is critically important to this process. Let's try another example to find out why. Okay, Yeah, I'm super glad that I switched to this. This is awesome. There we go. That's better. You know the problem with using tabs instead of spaces in my editor is that when I'm doing stuff like this, oh, hold on. Nope. Yeah, it used spaces. Oh, wait, there it is. There's a tab. But I can't tell what's spaces and what's tabs. So that's annoying. That's good. In GitHub, that does not work. It will tab you out of the input. And that's the case for many, many such things. I want all my examples to have the same format. Okay. Okay, this is kind of funny because we're like, okay, let's talk about the importance of keys. Oh, let's back up and talk about fundamentals of caching. So I wonder if we could I mean, maybe this is okay. It's just like repetition on the theme. Here, let's do this. Another example. There we go. And now we're going to talk about cache keys. Let's try another example. Or yeah, try another example. And then we'll dive into why. There we go. Because I really like starting out this where the cache is just a variable. I think that will really help that learning process here. And then expanding to, okay, we're going to use an object because we have multiple ones. And oh, now we've got a key. In our case, the in our situation, the key is the precision variable. Okay, this is good. Key to do. What in the world? That was weird. Oh, cool. My daughter's doing a presentation at school this afternoon. My wife just invited me. Pretty sure I don't have anything going on. I hope not. I would hate to cancel something so I can go see my daughter's presentation. Yeah. Cool. Yeah, we're good. Okay. Okay. they're two different things. Okay, I gotta think of another. Yeah, this is actually number 3. As a more practical example for number 2, let's say your I could use ChatGPT as an example. You want to cache the results of some conversation or something, but that would be ridiculous because they're basically infinite. Another example could be, let's see, building Google Flights. There are just so many combinations of I'm sure they have caching. They've got to have caching of some things. Let's try Salt Lake City to Ireland somewhere, or Stockholm. How do you spell Stockholm? Stockholm, there it is. All these filters, so many options. Like, it's just ridiculous. Yeah, I mean, maybe they're caching once you've searched it. Maybe. All right, let's test it out. So they're probably not gonna do cache headers and stuff, but let's just test the speed. It does not seem to go any faster. Yeah. Okay. So it doesn't appear that they are really doing much caching there, because it doesn't seem to go any faster when I go back and forth between selections that I've made. So I'm going to use it as an example. But it is break time, so I'm going to take a break. See you in a bit. All right. I guess I should count so I can give an idea. So we've got round trip. So it's, yeah, round trip, number of people, class, destinations, dates, once we get one in. So that's 7. And then 8, 9, well, and then that's like combinations of those. It's like so many. Let's call this 20,000 like combinations of these. So like yikes. Okay, we'll skip that one. And 10, 11. I think. Yeah, sure. 12, 13, 14, 15. 16. Yeah, okay. I gave up counting when I realized the combinations would be well over 100. That the number of inputs into the result basically means you'd almost never benefit from a cache value. As well as the fact that pricing changes regularly. And pricing changes regularly. This means the number of inputs to get the results basically means you'd almost never access the cached values. And perhaps they even customize the results to the user as well. But if we must cache, otherwise the app won't be usable. Here, let's say we must cache, otherwise the app won't be usable. So we decide it's okay to serve old values for some period of time, and then to reduce the impact, we can proactively update the cache. Okay. So let's talk about cache invalidation. Because, let's see. Maybe cache size would be a problem to talk about first, because part of the reason for cache invalidation is because of the cache size. So yeah, okay, this is fine. Yeah, often, or because we often need to make the trade-off of our cached values growing stale due to limitations of the cache key, we need to think about updating the values in our cache, or in some cases simply removing them. Well, we'll talk about that with cache size. There are a few approaches to this. My personal favorite is if you happen to know when an input changes, you can proactively update the cache value. Let's come up with another example that we can demonstrate in code. The MDX, here, let's do it. Oh, that's too bad. MDX, where's your website? .com, okay. That's a really good example. Here, let's also link this, I guess. I just want to be able to show an example that has actual code rather than just talking theoretically about an example. Got another example in the workshop app. I watch the file system for changes, and when those change, then I proactively update. Actually, I don't proactively update them. I just I use the last modified time as the key for the cache entry. That's an interesting idea there, but let's see. It's my favorite because it reduces the amount of time we serve stale values to users to as much as possible without unnecessarily recomputing the value. Okay. What's a simple example of a JavaScript function you can cache? Oh, let's do like, okay. This would be like when I update a blog post on GitHub. I have a GitHub action that runs and tells my running server to refetch the blog post contents. Which is exactly what I do. Let's look at, or let's try out a simple example in code. So here's our example. It's a simple and contrived example in code. So we have our user first name is Cody, last name koala. And we say function get display name user return user first name. Oop. Maybe this could be like a database query instead. So if yeah, let's just cache it right away. So display name cache function get display name cached user ID. So yeah, how do I always do that? We first do the check, or no, we calculate the key first. Yeah. Well, the key is going to be the user ID. It's fine. So if type of display name cache user ID it's not equal, or yeah, is undefined. Keep forgetting to do tab instead of 2 spaces. Then display name cache user ID equals, you know what, maybe I should do this in VS Code, because then I could get Copilot to autocomplete a bunch of stuff for me, which would be really nice. Oh well. Get display name user ID. This needs to be awaited. I'd also get formatting of the code, which would be nice too. Return that. Okay. Whoops. Now, with this cache, if the user changes their first or last name, our cached value will be wrong. So we can proactively update it. Whenever we update the cached or the user's name. First name, last name. Okay, so await, this could be async. This also needs to be async. DB update user by ID. Here, let's do this. All right, now I'm really starting to feel I need prettier. This is really annoying. All right. copy that. VS Code, where are you? Let's see, language, TypeScript. You know what? Forget this. Let's do language VX. Whoops. That way I can do all sorts of things in here. And we'll save it to desktop. Then I can save and get formatting and all that good stuff. Okay, rats. I need to fix my prettier default settings. Prettier. Oh man. Can I just do this? Or no, rats. Fine. There we go. Okay, great. So, yeah, we say update. We can close that and get rid of this. Huh, that's weird. Definitely thought that that would copy all of this stuff. Whoa. Okay. Copy. Paste. There we go. Okay. Yeah, those smart doodads, whatever. Yeah, okay. Update username, update user by ID, and then update display name cache. There we go. Okay. Fire and forget. Don't make the user wait for you to get your cache up to date. Unless it really matters. It could matter. See, this is what makes caching so tough. Huh. I think we're going to do a wait. And then I'll talk about how, in some cases, you might be able to do a fire and forget to not make them wait. Okay, there we go. There's our example. Here, no, let's not make that. We'll just stick this right here. there are actually now, so long, there are a few gotchas here. One, you're now requiring or updating the cache, or making the user wait for you to update the cache. This may be necessary because you don't want the user to see stale data after they update their information. But in some cases, you may be able to do a fire and forget, which cases it may not be necessary to make the user wait for the cache to update. Okay. Another gotcha. If you update the user's name anywhere else, you have to update the cache there as well. It can be a bit intrusive and easy to forget. Okay, just checking. Okay. I feel like there are a couple other gotchas that I was thinking of, and then I got distracted. Dang it. All right, 1 second. Okay. Okay. I think those are probably the two biggest gotchas. I feel like there was another one. Another thing you could, another approach to this is to simply delete the value from the cache. But if you can proactively update it, then why not? Which could be useful if you're uncertain the cached value will be needed anytime soon. Yeah, that's why not. Okay, so timed invalidation. If you're okay with the user getting stale values, and you're unable to keep track of when the cache value needs to be updated, then you can use a timed invalidation approach, which simply removes old values from the cache after a predetermined time. This is extremely common for generic caches, like those like content delivery networks, CDNs, and is even a part of the HTTP specification for browser caches via the content wait, what? Hold on. What is that header called? Cache max? Yep. No, that's not. Cache control. There it is. Control header. Using the max age directive, you can tell the browser how long to cache a resource for. For example, here, let's let Copilot give me an example. Why is that? That is so, what is wrong with you, Notion? Yeah, okay, that's fine. I deserve that. This will tell the browser to hang on to the resource in its own cache for 360 or 3,600 seconds. That's for 1 hour. The browser will not even, or so the next time the user or the browser needs, for example, let's say you put that on an image. The next time the browser needs to display that image, they won't even bother making the request to your server, they'll just check the browser or their own cache for it. So here, let's do the call out. Caches often have metadata associated with cached values. So in addition to the key, which in this case is the URL, browser caches also need to keep track of the max age, so it knows when to use the cached value and when to get an updated value from your server to keep track. Yeah. Whoops, sorry. The trouble with this is that once the user hits the max age time, they then need to wait to get the updated value. So they've been enjoying your Snappy app after getting the cache loaded, but all of a sudden they have to wait to update values in the cache after an hour of use. That's where stale while revalidate comes in. So this is stale while revalidate. If we're okay serving the user stale data, but here actually this does mean that you may revalidate the data unnecessarily, but if it's the best you got, then go for it. Okay. For okay, but we don't want to make users wait while we update cached values, then we can take a stale while revalidate approach. Okay, I think what we need here is either I need to come up with a code example or a diagram. I think we can do a code example. Let's check out a simple code and contrived code example to drive this idea home. Okay, so normally this is the sort of thing you need to do with third-party APIs that don't give you webhooks that tell you things have updated. So if we did like, let's say it's attendees at an event. So function here, let's do that over here. Get attendee count. Okay, and then function attendee count cache and this is a string. You know what would be sweet is if I didn't have to type this and it inferred the type based on its use. That would be crazy. So like this would work, and then if I tried to do anything else with it, then it'd be like, whoa, 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 you can't do that because you're doing this over here. Oh my gosh, that would be so sick. Yeah, that'd be sick. But no. You'd basically never use TypeScript as syntax. It would just no. That'd be so awesome. I mean, you could if you wanted to, like, return types and stuff, but okay. Attendee count cached. Okay, then we say if type of. Yep, that is exactly what I wanted. That's nice. And then that, and then we have here. Actually, let's also say here's our metadata value is this, and then the yeah, expires. Or we'd say time to live. No, that's, hold on, that created let's look at what Cachefied calls them. Yeah, that's what I want to go with. Created time. And it calls it value, right? I think that's what it's called inside. Yeah. All right, great. And then maybe, yeah. So set interval every every second, every 30 seconds. Boom, there we go. Or, no, even better. Never mind, forget that. we're not to the point where we're actually actively deleting stuff. If it's undefined or attendee dot hold on. Yeah. Okay, it's break time. I'm going to refactor this a little bit during the break. See you after the break. Sorry, not during the break. I will do it after the break. So I'll see you after the break. Okay. So I wanted to do this better. Pretty sure we could probably do update cache. We could do that. Or we could do this. There we go. That's nice. That is better. All right, good. I'm just wanting to make sure that stale while revalidate. Yeah. Okay. So if it's stale, then it can go this far beyond the stale time. Yeah, beyond expiration. Yeah, that's right. Why did that not go to max age? Do we have multiple elements? No. Weird. I think I need to talk about being fresh and stale. Okay. Yeah, this does get a fair bit more complicated. Hmm. Oh man, another thing to consider. Cache deduplication. When multiple things call a cached function at once before the cached value has been resolved. Okay, so if we want to serve stale, but we also still need to update the value. Serve stale is kind of I don't want to name that. Nope, it's actually more clear. Okay. So that's cache invalidation. Was there anything else about cache invalidation we should think about? Oh, yeah, forcing forcing fresh value. Often it's useful to bypass a cache and force a fresh value. I do this for my own site. Let's see, force the cache to be refreshed. This can be useful to manually update a cache value. For example, on my personal site, if you're the logged in as an admin and add fresh to most pages, the data on those pages will be refreshed, even if they've not expired. I'm unaware of any some CDNs support Fastify or Fastly purge. Some CDNs support a similar concept called purge requests like Fastly. That's kind of cool. I like that. I should actually add that to my site. This, yes. Talk about Fastly's soft purge feature. Yeah, that's awesome. I should totally add that to my site. So instead of forcing everything to be fresh, you can say everything's stale, and then it will refresh as it's used. Yeah, that's cool. Yeah, that's cool. Okay. But I am unaware of let's add that to our example above. Okay, so if we want to support force fresh, then you know what, maybe we should make all this stuff be parameterized time to live and stale or revalidate should be parameterized. Yeah, we should do that. Dang it. And I'm starting to think maybe this should be our example for all of the cache invalidation stuff. But no, we're only doing this because we don't have the knowledge we have here. You can do both, but yeah, we're gonna do a different example. Okay, so yeah, this will have TTL. Okay, forget that. Let's just grab this and we'll get all the nice formatting and whatnot. Okay. Okay. All right, great. So then we come here and say TTL and SWR. Okay. Here, let's okay. All right, so now we can enhance our example with force fresh. That would not be a thing in here, actually. I suppose we could say force fresh here. Yeah, that's stupid. There we go. Okay, great. So then we can say what's the easiest way to do this? Okay. To do, no, I'll just do it now. It's technically break time and I do want to take lunch, but let's finish this. I'm going to stop centered. And then we'll take my lunch break. So, see, I actually really like this soft purge thing. And so even though I don't do it this way, I think I want to implement it this way in the blog post. No. Force fresh, that's like a different feature altogether. So force fresh is make me wait for the fresh version, update it, and make me wait. So here's yeah, that's it. That's all. That's it. That's the easiest way to do that. Because otherwise you'd have to come down here and say, or if it's force fresh and serve stale and not force fresh, that would just be kind of weird. But here you say if it's force fresh, and then after that's done, it'll get the cache entry, and it will do this check, and it'll be like, oh, it's up to date, and it'll skip all that. Yep, that's what we're gonna do. With this implementation, you can now call get event attendee count cached with force fresh true as an option, and it will not, or it will ensure or make you wait for the cache to be updated before proceeding or to return you the latest version or the latest value. Fastly's soft purge. Okay, let's just link straight to that. Oops. Man, why when okay, so I'm focused here, and then I go here and then back. That's weird. Maybe it was because I had this up. That's probably why. Yeah, that's why. How annoying is that? Okay, Fastly soft purge. Is similar, except it does not immediately force the cached values to be updated, and instead just waits for those and waited for. Just waits for those, just sets those values as stale and past the SWR time. So the next time, or no, that's actually not true, sets them as stale. So the next time they're requested, they will be updated in the background. Very cool. How would we implement that? Would it be very hard? Soft purge. So if we say soft purge, then we will say we want to update, let's see, if soft purge, we're going to say value. Here, actually, let's just do this. We're just going to override the time to live will be 0, and SWR will be the .ttl plus date.now, or no, plus created at, or created time. There you go. Let's try that. And then we've got this. Soft purge does not, what this is doing is ensuring, no, this is actually totally not right. I think what we should do is actually have a function called soft purge. Yeah, soft purge event attendee count cache. Yeah, that's what we should do. Get rid of soft purge from this. That's what we do. Yep. That's it. Here, we'll get rid of that. It's just this function is all that matters. So all we do is update the TTL and SWR. Values to instantly ensure, or to ensure the TTL is marks this cached value as expired, but also keep the SWR time intact. So intact, is that not how you spell intact? Okay. So the next request still gets the cached, or the next request cached value, or next call instantly, but also kicks off an update in the background. This has the benefit of not immediately putting pressure on our server to update all cached values at once, and instead can get them updated over time. Pretty slick. Okay, yeah, that's cool. And that makes me want to request this feature. Add support for soft purge. More details here. I'm writing a blog post about caching, and here's how I implement it in my simple example. Take that, stick it there. And basically just that. All right, we'll see what is said there. And now I think we can finally stop talking about cache invalidation. Yikes. This is quite the post. I knew it was going to be really big. But yeah, so we'll talk about cache size next. That's when we get into where do you store your cache, and then loading the cache and cache deduplication. Cache, yeah, we'll figure out what to call that later. All right, that's it for this this morning's stream. I'll be streaming more of this after lunch. Take care, everybody. Bye.